So the detection, we choose to design an electrochemical biosensor array. As it comes is just generic electrodes. We have between 60, so it's a low density array for those of you who might be used to the typical microarrays used in proteomics or genomics. We have an array of between 60 and 70 electrodes depending on the configuration. And each electrode needs to be functionalized with the corresponding probes for one of the 20 markers that we are looking for. So what we do, if you imagine this surface is the surface of the electrode and not of a microtiter plate as labeled, we actually anchor down a probe for the MLPA product. We then present the MLPA amplified target sequences coming out from the amplification modules, which should hybridize very nicely to the surface. And this we are able to, these single events, we can measure it electrochemically, although it's not that sensitive and we struggle to reach the limits of detection we require. So we came up with another strategy where we have a reporter probe that can hybridize to the top of the hybrid, into which we can put a label. It can be a single enzyme label or it can be an electroactive molecules. We could also label what we call here primer X, that is basically lying on the surface, and that allows us to reach the detection limits we are after. So a few electrochemical detection strategies that we've investigated. In terms of actuating the microfluidic chips, the less washing and measuring, the less washing and labeling steps you can include, the better. So we looked at two steps that actually needed wash and labeling, and two others that were actually pretty washless. In the first case, we took one enzyme, a single enzyme label, and that's in our case we use HRP. That works really well. We went down to a limit of detection around 50 picomolar of the DNA we're after. So that's a single enzyme label. What we also looked at are liposomes-based labels. Liposomes are lipid vesicles into which you can encapsulate a number of those enzymes and hope for a signal amplification. And then as washless methods, what we could do is include in the MLPA mix some primers that were already labeled with some electroactive probes. So here you see the ferrocene moiety that is lying on the surface, and we can detect that upon hybridization. Another format is the known molecular beacon thing, where you have a probe which forms an hairpin on the surface, where at the end you have an electroactive molecule like ferrocene that is in contact, and that is an on state, if you wish. And upon hybridization, the complex just straighten up and take away the electroactive units from the surface, putting it in an offset. The integration of the modules, this was another very challenging part, where here you can see some pumps, the incubation modules we just presented earlier on, the heating and cooling elements of the amplification modules, and the place for the detection module. Underneath you see a few motors to actuate the whole thing, and the cartridges for buffers and solution needed for PCR and to drive the samples around.
1 minute.
Okay, so we judge the successfulness of the success of our project by the numbers of commercial products that managed to be spin out of the project. As academics, we personally am after publications, but the commercial partners, they want products, and the EU as well. So what we have so far, we have a number of modules produced by IMM in conjunction with the commercial partner. For Adnagen, they're into launching the micromodule for cell isolation. Similarly, MRC Holland, which is the expert in MLPA, has developed a full MLPA kit for breast cancer monitoring that's being launched soon. And similarly, I'm interested in a micromodule to perform all this on a chip. And more generally, we have the MLPA array kit for specific breast cancers. Fujirebio has developed a whole set of cell surface markers for breast cancer and lung cancer that are launching also. And Adna Collect is ready to launch the cell stabilization buffer, which apparently works very well. To come, there is again a few things around the micromodules. So we have the micromodules for cells counting from IMEC, the MLPA generic sensor array, which is between MRC Holland, URV for the detection, and IMM for the whole manufacturing. AdnaGen and Fujirebio are planning to commercialize a cell isolation kit especially for lung cancers. And then each module, as it becomes integrated, becomes a product in itself. As I said, we focused on breast cancer, but you can imagine that if you change the chemistry either of the PCR or the cell surface markers that you're looking for, then we could start looking at fetal cells. We've been looking at circulating tumor cells, but from other cancers. And the isolation and characterization of the disseminated tumor cells, and also stem cell in blood and bone marrow. And that brings an end to my presentation. I'd like to acknowledge all the partners. You have all the logos here, and thanks the European Commission for their funding. Thank you very much.